All right, on to section 3.5, angles of a polygon, which follows the angles of a triangle section that we just did. That's interesting. Oh, sorry, I got ketchup on my shirt. That's got to be distracting, but hopefully we can get through this. All right, what does polygon mean? It means many angles. Poly means many, gon means angles. A lot of people say it means many sides, but the source that I have says it means many angles. I'll trust them. Polygons, like triangles, have vertices, sides, angles, and exterior angles. Those are all terms that we talked about when we talked about triangles. There's a good reason for that. Polygons are named by listing consecutive vertices in order. So this over here is hexagon, A, B, C, D, E, F. Okay, so we just got to start and then go around and list them in order. We can go the other way around as well, and A, F, E, D, C, B. We could start with D and go D, E, F, A, B, C. It doesn't matter at all. What you cannot do is name them out of order. Okay, but we can name a polygon just simply by naming the consecutive vertices. A diagonal is a segment that connects two non-consecutive vertices. Think about this for a second. If we're connecting two consecutive vertices, like A and F, segment AF isn't a diagonal, it is a side of that polygon right there. So these are examples of the diagonals that come from vertex F right there. Segment FB, segment FC, segment FD. These are some more, segment AC, segment EC. There's plenty others here that we could draw, but anytime we connect two non-consecutive vertices from a polygon, that's a diagonal. Two more terms here that show up are this convex and non-convex, or non-convex is also a concave. One definition here for convex is that there's no part of a diagonal outside of the polygon, or simply that all diagonals are interior. This set right here, these are not polygons. We have curved sides here, we have sides that intersect here, don't even have sides here, just two intersecting lines. These are not polygons. These here are convex polygons. Any diagonal that you draw will not be outside the polygon. So what is a non-convex polygon or a concave? It has diagonals that are external to the polygon. These down here are these are non-convex, or they are concave. Look at these diagonals here. This diagonal is clearly outside, so is this one. If we draw the star here, these are convex. These diagonals are outside of it. Also, consider this. What is a cave? A cave goes inside. You may have heard these terms, convex and concave, related to like lenses in science. But if you think of a bowl that you put cereal into is concave. It holds stuff. It goes inward. These are concave. It kind of goes inward. This goes inward. This goes inward. A convex polygon is like, imagine turning a bowl over, and then it's just, it will hold nothing. These are convex. It holds nothing. It sticks outward. If you think about belly buttons, there's a difference between an outie and an innie. We should call them convex and concave. Anyway, you'll be asked to identify some things as convex and concave. The diagonal thing is the easiest way of determining that. You probably know many of these, but we need to know the names of polygons. Three-sided polygon or three-angled polygon is a triangle. We have quadrilateral. I've heard the term quadrangle as well, but quadrilateral is what these are typically called. 5 sides, pentagon. 6 sides, hexagon. Septagon or heptagon. There's two common terms for 7-sided polygon. Octagon, nonagon for 9-sided. Decagon here for 10. Think about September, October, November, December, of course, thanks to the Romans with July and August. They threw those in to screw up the ninth month of September, etc. A dodecagon is a 12-sided shape. So if we're talking about any sided shape that's another just maybe random, there are other terms, but we'll use n-gon to represent just a general side. The 3 through 12 that I have listed here, I want you to know. But if we're talking about like a 17-sided shape, we'll simply call it just a 17-gon. All right, now, all right, before we go on here, let's do this little exercise here. Let's consider polygons with different sides, the number of triangles they have, the sum of their interior angles, and the sum of the exterior angles. Just follow along here with me. We've got a triangle. Let's say these are the angles of the triangle. We all know that by now those add up to 180. Let's talk external angles. Well, if this one angle over here is 40 degrees, its exterior angle is 140, right? What's exterior of 60 degrees? That's 120. What's exterior of 80 degrees? That's 100. So what we find here is how many triangles are there in one triangle? Well, that's not a trick question. There's one triangle in a triangle. The sum of the internal angles are 180. The sum of the exterior angles are 360. 140 plus 120 plus 100 is 360 degrees. There's some other reasons that I could show you for that, but just know this. The sum of the exterior angles are equal to 360. Consider a quadrilateral. Here's the purest form that most people think of when they think of a quadrilateral, a square. All the angles are 90 degrees. All of the exterior angles are 90 degrees. So there are 4 sides. And when I'm talking about number of triangles, if I draw a diagonal here, how many triangles does it create? 1. I could draw another diagonal and create. But from a single vertex, how many triangles can I create? There's 2. 2 triangles. So what's the sum of those angles? 360 degrees. Of the 2 triangles would be 360 degrees. So I showed you that one 2 different ways. Consider a pentagon. How many triangles make a pentagon if you draw diagonals from a single vertex? All of the angles of this triangle and then this triangle and this triangle, these 3 triangles, make up the angles of the pentagons. If you consider angle addition postulate right there. So what's the sum of all those? Well, there's 3 triangles. Each triangle has 180 degrees, so 3 times 180 is 540. The sum of the exterior angles, you guessed it, is 360. I hope that you're starting to see some patterns here. If we have 6 sides, how many triangles are there? 4. There are 4 triangles. So the sum of the interior angles would be 4 times 180. Each triangle is 180 degrees, 4 of them. 4 times 180 is 720. What pattern are you seeing? If there's an 8-sided shape, how many triangles will it have? I'm not going to draw it for you this time. What's the pattern been? Well, 2 less than the number of sides is the number of triangles that we have. So there would be 6 triangles, so we're going to multiply 180 times 6 to get 1080. The sum of the exterior angles is 360. If you have a 16-sided shape, there'd be 14 triangles, 14 times 180, then 360. So here's where we get to the root of it. If you have n sides, how many triangles would there be? 2 less than n. Okay, how would you figure out the sum? Well, we'd multiply 2 less than n times 180. And then, of course, the sum of the exterior angles is 360. This, my dear friends, is the formula we're going to use. So back to our concept guide. The sum of the measures of the angles of a convex polygon with n sides is, this is just what we figured out, n minus 2 times 180 degrees. So, example A, if you have a hexagon, find the sum of its angles. Well, take 2 away from 6. 6 minus 2 is 4. Times 180 is 720 degrees. It's a simple calculation once you understand it. The polygon exterior angle sum theorem. The sum of the measures of the exterior angles of a complex polygon with any amount of sides is 360 degrees. It doesn't matter. If you have a polygon, the exterior angles equal 360. So example A, part B, the sum of the exterior angles of a hexagon is, who cares how many sides? 360 degrees. So see if you can figure out these 8 down here. If you have a quadrilateral, I'll do this first one with you. The sum of its angles, take 2 away from 4, times 180 is 360. The sum of the exterior angles is always 360. See if you can calculate the remaining 7. A little bit of calculator work. This takes no time. Pause. Hope these are the answers that you got. We continue. Oops. Okay, we continue. This is what kind of a shape? 1, 2, 3, 4, 5. There's 5 sides, 5 angles. This is a pentagon. So the 5 sides, the sum would be 540 degrees. Well, if these 4 angles all up to 490, this plus these 5 angles together all have to add up to 540, right? So 540 minus 490 equals 50. See if you can figure out x on 10, 11, and 12. We had a quadrilateral and then a hexagon here, so hopefully you found those sums and then subtracted them. Number 12 is slightly more tricky. It's a quadrilateral. What's that sum? 360. So x plus 60 equals 360. Did you figure that out? When we solve, we get x equals 100. All right, regular polygons. This is a special, specific type of polygon. We've actually been talking around these a while. A regular polygon is a polygon that is both equiangular, all the angles are congruent, and equilateral, all the sides are congruent. So, back to our hexagon. Find the measure of each angle of a regular hexagon. Okay? Well, the sum of a regular hexagon would be 4 times 180, 720 degrees. So to figure out what each individual one, we're going to divide by the number of angles. 720 divided by 6 is 120. To find the measure of each exterior angle, we're simply going to take the sum of the exterior angles and divide by the number of angles, which would be 6, or number of vertices, really, in this case. So it's 360 divided by 6 for that. Piece of cake, right? Just take the sum of the internal angles and the exterior angles and divide by the number of angles. All there is to it. Give it a shot. 13 through 20. Go. Little calculator work takes no time. These are the answers you should get. What I want you to pay attention to here as well is the internal angles and the exterior angles are all supplementary. 108, 72, 135, 45, 140, 40. You can go the other way. If you figure out, if you know what an exterior angle is, you know what the internal angle is. If this is 120, that's got to be 60. If this is 24, that's got to be 156, etc., 36, 144. They are supplementary. That's going to make life easier, especially when we get down to this bottom section. In this bottom section, we're going to be given in a regular polygon a measure of one of the angles. Now consider this. So if 360 divided by n is equal to an exterior angle, if we manipulate this right here, we can take 360 divided by the measure of the exterior angle and get n, the number of sides. 360 divided by a single exterior angle equals n. So check this out. If the measure of an exterior angle is 45, how many sides does the regular polygon have? We could do this a long way. 360 divided by n equals 45, but all we're going to do to get that answer is take 360 and divide by 45 to get 8. 360 divided by 45 is 8. 360 divided by the exterior angle is 8. I'm going to do this the long way for you on question F right here. Don't do it this way, but watch. So n minus 2 times 180 divided by n is 150. Whatever n is, we don't know the number of sides. Minus 2 times 180 divided by the number of sides will get us this angle measure of 150. If I do this, all right, we can use algebra and then go solve this equation, and we'll end up getting that n is equal to 12. There's a much easier way. Watch this. If the measure of the interior angle is 150, what's the measure of the exterior angle? They're supplementary. Oh, that's right. It's 30 degrees. And then what did we just learn? If you take 360 and divide it by an exterior angle, you get the number of sides. What's n? 12. Take your pick, the red way there or the purple way. Hey, if you're still paying attention, write the word gone above example C. G-O-N-E, polygon. I don't know, it's something. Just try it. There's 6 questions down here. I want you to try those as well, and then you'll be done. With a little bit of calculator work, this takes no time. Pause, try. So did you just get 360 divided by 60 is 6, 360 divided by 15 is 24, etc.? Here, did you go, all right, if the interior angle rather is 60, the exterior angle is 120, 360 divided by 120 is 3. If that's 160, that exterior angle has got to be 20. 360 divided by 20 is 18. Did you do that? That's all there is to it. People, that is section 3.5. Get some rest. Man, there's a lot of stuff going on. And come see me if you need some help. Thanks.